many methods like chemical vapor deposition, thermal polymerization, template assisted methods, micro and ultrasound assisted methods. All methods are useful. Still some methods. So all and in the field it was not so much explored. So by the literature review who found the research gap and different materials there are so many precursors in the nature, but do we have how many precursors for the synthesis of carbon, and here the used in the range of 500 to 550 degrees centigrade, ideal temperature for the synthesis of graphite carbon. The most important key parameters during the carbon, the most important thing is that temperature that is nearly 50 degrees centigrade. That is the suitable temperature for the synthesis of graphite carbon nitride. Secondly, the reaction time is very important. Nearly 4 hours is meant to be ideal. That is such a very part of the also, but the less porous structure and whether the reaction may not proceed to the final step. What is the heating rate? We have heating rates in different, that is 5 degrees centigrade per minute, 10 degrees centigrade per minute in our furnace. But it was optimized, it was found that 5 degrees centigrade per minute was the best to prepare the graphite carbon nitride. And by all these three conditions, the stability is enhanced, moreover, layer thickness is reduced, and interlayer spacing is increased. And all these three important features give an important role in catalysis. This is the preparation method, how the G3N4 works. First of all, urea converts to isocyanic acid, then isocyanic converts to further balance, and then this is the pathway as proposed by Francis in this word. And the important role of urea is that release ammonia, create the pore formation and supply the nitrogen posture to G3N4, which is very important for the catalysis step. In the literature, there are so many materials available for the carbon nitride modifications. Several researchers have modified it with metal oxide, several with non-metals, several with carbon materials, and several with conducting polymers to expertise their different fields research. In the present work, we have prepared the 4 modifications of graphite carbon nitride. I am presenting here too. So firstly, we have modified graphite carbon nitride with sulfonic acid. So first of all, the graphite carbon nitride was prepared using urea powder that is taken in a single crucible and Fahrenheit at 550 centigrade, and then we get the variable solid. This variable solid is taken in a 2-leg groundwater flask and easier to add to it, and it was magnetically stirred, and finally it is addition of fluoric acid in ice cool temperature, and then we obtain the material and we run the heating for 6 hours at room temperature, further followed by the material certification, and then dry it and we get the graphite carbon nitride sulfonic acid. Further, we have prepared the material in right form or not, so we conducted analysis. We performed the FTIR spectrum of urea and G3N4 and graphite carbon nitride, and it was found that the NH peaks are very common in all these three, but the presence of this CNS peak and SO peak confirms the formation of graphite carbon nitride, that is the indulgence of sulfur in the graphite carbon nitride material. Then we performed the XRD studies. In XRD, there was found that 2 peaks in the range of 12.17 and 27.92. And it was found that the first peak is due to the repeating phase of the monomers, and the second peak, that is 002, is due to the absorption of sulfonic acid on the layer, that is the interlayer spacing was covered with this. Further, we continued with the SEM studies and TEM studies. It was found that the structure is highly porous, with morphology, there is a 17% weight loss that is possibly due to the evaporation of absorbed moisture and volatile compounds. Further 6% loss is not seen in the GC3 and 4, but it is found in the GC3 and 4 maybe due to the presence of the sulfonic groups which can retract or break down. And finally, 700 degree centigrade was completely break down. That is, I could say, the material is stable before 700 degree centigrade, and that's a good choice for this material. Sulfonic acid to further increase the substance of this catalyst. So this we are done with. We undergone with these two different steps. For media powder, we prepare the CNS as the progress, and in the second chapter, we take the amla seed powder. Amla seeds dry and prepare the material, and this biolyzed, and we get the biochar. We take the material 10 gram, and we get the biochar 0.998 gram. And further, this biochar and the GC3 and 4 were merged and biolyzed and washed, and we get the biochar modified carbon sulfonic acid. Further, the studies were carried out, that is FTIR, and here we also get the peak. This CM and CMC double bond and peaks are in the range of 1000 to 1400, and the SOP and CS peaks are in the range of 600 to 800. These peaks confirm the structure or the presence of functional group in the DCN. Further, the study was also studied in this material, and it was found that this peak is for we have characterized different materials, that is urea, GC3 and 4, GC3 and 4 SO3H and biochar, and it was found that the peaks remain same in the sulfonic acid and in the biochar. New peak arises, and this peak diminishes. This leads to the confirmation that the material has been aggregate spacing has been increased, and further a new peak confirms the presence of crystallinity. Further, the cell images were taken to check the porosity and the layered morphology of the material. Further, the EDX mapping and EDX studies were done to confirm the constitutional constitution of this catalyst, and it was found that carbon, nitrogen, oxygen, sulfur is found in the different percentage, confirming the presence of these elements in our material. Further, TGA was performed, and it was also found that this material is more stable than the graphitic nitrite sulfonic acid, and this material is stable up to this 500 degree, only 19% loss, and in the previous 16%, there is 22% loss in the graphitic carbon nitride sulfonic acid. Means we have modified the material and we get the more thermal stability of this material. After preparing all these catalysts, we further applied them in the catalysis for the synthesis of 1,1-dihomoaryridine scaffolds. Here we have prepared this diamidone, this purine, this parazolone. This is a graphical study, graphical extract for the synthesized molecules. We have prepared different about 22 to 26 molecules, and most of the compounds are new, and we further check their study. This is the reaction optimization, different solvent systems, different temperature systems, and different amount of the catalyst was taken, and it was studied that G3H was found H2O solvent system H2O at room temperature we get the more gas release in 10 minutes. Further, the optimization for bisphenol, and it was found that bisphenol was also found in the water ethanol solvent H2O at room temperature for 20 minutes. We get the best yield, that is 96%. Further optimization for the biscuit scaffolds, we found that at the room temperature the yield was not good enough. So we performed the reverse conditions and 80 degrees centigrade for ethanol, and it was found that 96% yield in 35 minutes. This is the schematic presentation of the different derivatives we have prepared in our laboratory. 14 derivatives for this cyclohexane and this diamidone. For the bispyranones we have prepared 6 derivatives, and for the biscumine we have prepared 6 derivatives. Most of the derivatives are new and are not reported till that time. This is the library of synthesized compounds. We have taken different types of aldehydes, that is the electron withdrawing group, electron donating group, and the polycyclic compounds to check the stability and the structural viability of these products. This is the NMR spectra of the synthesized compounds, because without characterization we can't say that the compound has been formed or not, because we getting PLC a single point, that is not the confirmation for the compound. So we perform the 1H NMR and 13C NMR. Due to a shortage of time, I am just skipping, I am not explaining these. This is the mechanism for the synthesized compound. Basically what happens, this graphite carbon hydride activates the carbonyl group of this aldehyde and undergoes interaction with this sulfuric acid hydrogen, that is the hydrogen bonding, and then further undergoes non-rigid condensation with the removal of water to form this intermediate. This intermediate undergoes reaction with the second molecule of this CH activated compound followed by nitric addition, and we get this compound. These compounds may be disranulone depending upon the reactant. Finally, for the green chemistry, it is very necessary that catalyst can be reusable after so many cycles, because get wasted in the first cycle, then it has of no use. So following the green chemistry principles, we followed the reusability studies, and it was found that the catalyst was active for 6 cycles with a very less loss in the catalytic activity, and the catalyst study was confirmed by IR and XRD, and it was found that the catalyst structure has not been distorted and the sulfuric groups are present there. Further, for the industrial scale level, we have performed the gram scale synthesis, and for the in the gram scale, we get the good yield of these compounds. It confirms that catalyst can be introduced at the industrial level. For the second quantity, we have prepared this indoors using BCNSA. Here we have prepared the BCNSA and applied for the synthesis of this indoors using isatine, indoors, aldehydes or ketones, and cyclocompounds. Here the beautiful thing of this study is the operational simplicity, that is the reaction is performed in water at room temperature and using very less amount of catalyst. Here we have prepared a new derivative with very high yields and less reaction time. So this is the synthetic aspects of this reaction. We have prepared 21 derivatives and the 10 derivatives are completely new. So this is the optimization of the reaction conditions for a model reaction, and it was found that the reactions are performed at room temperature in water solvent using 20 mg of the catalyst, and we got the 85% yield of the product. This is the library of synthesized compound. All compounds are well characterized by 1H NMR, 13C NMR, and the HRMs. The mechanism goes on similarly as previously I reported, that the activation of oxygen of carbonyl group followed by non-rigid condensation and micro reactions, we get the product this into. These are the 1H NMR and 13C NMR of the synthesized compound. Finally, the catalyst reusability study was also performed for this body also, and it was found the catalyst was reusable up to the 7 cycles, and very less leaching of the catalyst was found. We have performed the gram scale synthesis. You can see that how much amount has been prepared in just 35 minutes. Further, to evaluate the greenness of the reaction, we also calculated the green matrix of the reaction, and we found that the reaction is very green, that is having the very low E factor, high atomic economy, high reaction mass efficiency, high process mass intensity, and high eco score. All these factors confirm the greenness of the reaction, that is not polluting the environment. So finally, I can conclude that we have prepared 21 plus 26, that is 47 derivatives in the completely green conditions at room temperature in the water solvent, and we have prepared some new derivatives that can be analyzed for the biological purpose. So excellent green chemistry matrix, moreover successful gram scale synthesis. So all these points give important ideas for further study of GC3N4, and we have prepared 2 more variations in this catalyst. But all the literature from 2006 to 2025, but still there are some challenges for this material. That is, this material should be studied well. Most of the scientists are working on the modifications of GC4 with different materials, all matters and others. But this may lead to pollution of the environment. So there is a don't need to develop and design sustainable synthesis technique that have precise control over the morphology, composition, and the interfacial structure of these CNS. Moreover, there will be there should be some expertise for the synthesis of these CN materials so that without addition of noble metals or semiconductors. And the multi-step protocol should be avoided because when we use the multi-step, the material efficiency on the yield will be reduced. Moreover, it can be done that is ternary and quaternary combination with advanced material can be done so as to develop this material in more efficient way. For the more challenges, it is very necessary because in the photocatalysis there is an electron hole pair formation and the recombination. So there should be some computer modeling. As I said, that is a very important tool. So you can use a computer modeling technique to rationalize the design of photocatalysis. Moreover, bandgap of GC3 and 4 is 2.7. That is a visible range technique. But for the solar-driven water splitting, this bandgap should be near to 1.8 eV. And this bandgap has not reached in the science till date. So there is a very much need to reduce the bandgap by different modifications. Moreover, in the future, it is a very promising candidate for the next generation. Applications received during the last 4 years. We are working on this material for the last 4 years. I sincerely acknowledge Department of Chemistry MLSU for providing the necessary research facilities, Department of Physics, IIT Jammu, IIT Bombay, IIT Madras, and Seth Chandigarh for different analysis. Moreover, the RUSA, MHRD RUSA has given 4.75 crore to our department for the purchase of NMR. We have in year 2022 we have purchased 400 megawatt NMR, and this NMR has made the research a bit faster and easier for us. And I have already one project of another cure of 30 lakhs received in the year 2020. This is a few glimpses of my work during the last 10 to 12 years. This is my team. 6 have been awarded PhD and 4 are working under my supervision. Thank you.
Thank you very much for giving us inspiring and very good lecture. But this time is a very complex time between the breakfast and lunch. We are also thankful to all participants for giving us valuable time. Thank you once again.
I would like to request Dr. NI Professor to felicitate Agrawal ma'am with bouquet and I would like to invite Chana sir to felicitate NI Professor with the certificate and bouquet.
Now, thank you very much, sir. Now it's time for